Alright, welcome everybody. By this point in Module 1, you should have reviewed the entire research process, so if you haven't done so, please go ahead and view those videos first, and then we'll move on to these final two videos on first validity and then reliability, two key aspects of research design. So, again, quick review. We've talked about different forms of research designs, the information they can and cannot give us. Imagine that we've picked our design types and now we're kind of figuring out the nuts and bolts. What is that study going to look like? How is it actually going to run? So obviously we want the study that gives us the best information possible. We're already making some compromises. We are using operational definitions because we can't directly measure the variables we like. We're measuring samples because we can't directly measure entire populations. We need to make sure the data we're getting is as strong as possible. So that brings us to these closely linked concepts of reliability and validity. So here's the main idea. Remember again that we use a lot of hypothetical constructs and we represent them indirectly. We find a way of translating it into a concrete form that we can work with. We can get those numbers from, that data that we're looking for. Those are called operational definitions. So here's the big issue. We want to make sure those operational definitions are good representations of that construct that we're actually interested in. Because it's an indirect way of representing it, it's essential that it be as closely linked to the real construct as possible. So sometimes it can be very intuitive. Sometimes it's not hard at all and there's a clear match. Sometimes our variables aren't even hypothetical constructs, like our cell phone and driving example that we talked about, where their variable is did you use a cell phone or not. That's not a hypothetical construct. But when we do make that jump, sometimes we have intuition to kind of inform us. For example, if I wanted to measure persistence, I give someone a task that's impossible to solve and I see how long they keep trying. That seems like a very intuitive way of representing persistence. If I'm looking at prosocial or helping behavior, I have a confederate, not someone who fought for the South, but someone who's working with the experimenter, but the participant doesn't know it. I have them in a situation where they appear to be in distress. I see if the person's willing to help them. That's an intuitive way of representing prosocial behavior. If I want to measure people's positive mood, one way I could represent it is just count how often people smile during a study. Again, intuitive. It makes sense. So intuition can help. It can give us some really logical operational definitions, but it's not enough overall. We need something that can kind of verify that our operational definitions are good. Here's where reliability and validity come in. These are sort of dimensions that our measurements, the way we have of representing variables, can have that can lead to them being more or less useful. Ideally, we want both of them to be as high as possible, but as we'll see, there's trade-offs that come into play a lot of times. We're going to start by talking about validity. We'll talk about reliability in a separate lecture. Validity is all about accuracy. It's the extent to which our representations of those constructs, our operational definitions, are measuring the constructs that we want them to measure. So we're all about accuracy. Are we as close to that construct as possible? Again, just assessing the construct accurately is all that matters with validity. It doesn't matter if your measures are consistent. We want them to be consistent, but that's a different thing. That's reliability. Validity is just all about accuracy. Are your measurements, at least on average, measuring that construct accurately? Is it a good representation of it? So when we talk about validity, we usually talk about different subcategories, and they're called internal and external validity, and you can think of it as validity or accuracy inside the study for internal stuff, and validity or accuracy outside the study for the external stuff. So we'll start with the internal piece. Internal validity looks at the notion of whether or not our measurements reflect only the variables we're interested in and only the variables we're trying to assess. Here's why that's important. It's very, very easy to accidentally, through poor design, create situations where we're measuring the wrong thing, or sometimes kind of more sneakily, we're measuring the right thing, but we're also measuring something else at the same time, and we're not able to separate those as well. That instance where we have sort of multiple things that we aren't sort of accounting for are called confounds. A confound is any variable that you aren't measuring or manipulating that changes at the same time the independent variable does in an experiment or in a correlational study at the same time as the variable of interest. Here's why that's important. Let's say I'm trying to manipulate an independent variable. To be sure that IV is causing changes in the DV, that needs to be the only consistent difference between my conditions. If there are accidentally two things that are different between my conditions, the independent variable and some confound that I didn't even think about, then even if I get the results I wanted, I don't know if the IV caused those differences, I don't know if the confound caused those differences, or if it was both of them at the same time, if they had a combined influence. I can't tell. It kicks the legs out from under the conclusions that I can draw. So confounds are hugely damaging to internal validity because you no longer know if your results reflect the actual relationships you're looking for. So a classic example from a correlational study, we'll talk about an experimental one in a minute. There was a line of research about 20 years ago that found that children whose moms basically played them classical music in the womb wound up having higher IQs than kids whose moms didn't. So people did the correlation causation mistake and said, we need to play Mozart for all of our unborn babies and they'll get super smart, we'll save money on schooling. And of course, people started looking into that and they said, well, okay, the children whose parents played classical music for them, those parents tended to have higher IQs to begin with. So these kids wound up with higher IQs, but is it because they listened to classical music in the womb? Or is it because they had smarter parents and that led to genetically and kind of environmentally the tendency to develop higher IQs themselves? So parental IQ, not health, would be the confound in that case. Eliminating or controlling those potential confounds is key to maximizing that internal validity, being as confident as possible that you're measuring only the things that you want. So here's kind of an interesting example of a confound in the real world. So some of the older students in particular might have heard of the Pepsi Challenge. And the whole premise of the Pepsi Challenge was executives at Pepsi are sitting around and they're saying, gosh, we sure do sell a lot of soda, but we don't sell as much soda as Coca-Cola does. We're number 2. We're not as popular. We think people who like Coca-Cola mostly are just used to buying it. They just have brand loyalty. We think they would like the taste of our cola, our soda better if we just remove the labels from it. So they designed a blind taste test. They went out in public and gave this to thousands and thousands of people. In this taste test, you got 2 cups of cola. Coca-Cola was in a cup labeled as brand Q. And then here's brand Q. Now, Q has nothing to do with Coca-Cola, so they figure that's a good way of representing it. Pepsi was given to you in a cup, and you're told, here's brand M. So again, Q and M, nothing to do with the actual original names of the soda, so you're not going to know which is which from those names. You're going to taste these 2 sodas in random order, and then you're just going to tell them which one you like the best. What they found was that most tasters reported they liked the taste of brand M the best. That's great. That's Pepsi. That's what they wanted to happen. They launched a huge advertising campaign about this. Take the Pepsi challenge, do a blind taste test. You're going to love it. You're going to buy more of our soda, and we'll all make more money. So again, their argument is that when you remove the labels, people preferred Pepsi because they didn't know what soda they were drinking. They were more honest about which one tasted the better. However, can you spot the confound in this study? There's something that differed between those 2 conditions other than the kind of soda that was in the cup. See if you can think about that. And we'll identify it in just a second. Here's how it was identified. Coca-Cola said, well, we'd like to continue selling more soda than you, so we're going to try to kick the legs out from under your conclusions. We're going to do a replication of your design, but we're going to make one little tweak. Here's what we're going to do. Again, same design. Participants are going to get 2 cups of cola. One has brand Q on it, one has brand M on it. You randomly assign what order they get those cups in. But in brand Q, just like the first study, there's Coca-Cola in the cup. In brand M, though, there's also Coca-Cola in the cup. Participants drank 2 glasses of identical cola. There was no difference between what was in the glasses. And they said, which one do you like the better? And most people still liked brand M better. It's kind of odd, isn't it? Even though the drinks were exactly the same, what letter was attached to it seemed to influence people's preferences. Maybe M is a more common letter than Q. Maybe it's just more aesthetically pleasing. I don't know. But the point is here is that confounds can be very subtle. It's not necessarily the things that you would expect. You wouldn't expect whether it's called Q or M to affect people's preference ratings of the flavor, but it did. It very consistently did. So confounds can be very subtle, but they are very, very influential. We can no longer say that people preferred brand M because Pepsi was in it. It might just be because of the letter M was involved. So that's internal validity, accuracy inside the study. External validity is a little quicker to explain. It's what we call accuracy outside of the study. So remember, we never care only about the people in our study, only in the context of our study. That's trivia. We want to do what's called generalizing. We want to generalize to much larger groups of people, our populations. We want to generalize to real-world situations, not the way people behave in little lab rooms and psych buildings or wherever we're testing them. So One of the big questions of external validity is our sample similar enough to the population? We talked about that idea of representative sample back in the research process material. Remember we talked about that college student problem. Most samples are convenient samples. They're who's available to the researcher. That's usually college students. College students, not a representative sample. The way they act may not reflect those bigger populations of, say, adults overall. We can improve external validity by, again, repeating the same study with different samples. Again, if you keep seeing the same pattern of results over and over and over again with different samples and different operational definitions, it really, really supports the idea that your results aren't a fluke, that there's a legitimate relationship that really does exist at the population level. We also can do what's called meta-analysis. Meta-analysis is a very advanced stats technique, but basically you take every study you can find on a topic, you throw them in a big statistical blender, and it spits out the average size of the result. So really high level stuff, but it's a common approach for increasing external validity. Basically, it gives you the punch of 100 different studies or however many have been run all in one kind of data set. A subcategory of external validity is ecological validity. We usually test people in unnatural environments. They know they're in a study. They know they're being assessed. Is their behavior natural? Does it reflect that real world behavior that we actually care about? Hard to say sometimes. That's the ecological validity. Does this generalize to how people naturally behave in a real world scenario? If not, again, results can be as accurate as you want. They're trivial. They don't really tell you much. So that's the end of this lecture on validity. The next lecture will discuss the kind of sibling topic of reliability, and we'll talk about reliability and validity together. See you there.